Hello, and welcome to how the packet firewall can protect your enterprise. Before we actually get started, thanks for everybody for coming to the talk. I know there was another talk on security that I actually wanted to go to, but I think I had to come here to give this one. So that's super awesome. Thanks for coming. Just before we even get started, how many people have ever used or heard of PF? Sweet. For those who have, I hope you enjoyed the talk. And maybe you'll learn something, maybe you won't. You can add to my knowledge ability as well. So I'm super I'm looking forward to that happening. And for those who have not, hope this provides a framework for you to implement PF on your clients and or in your enterprise. And I should have thought about not using this laptop because my privacy filter is making it hard to read my notes. But just to let you know, so who am I? You know, why they kind of allow me to speak here at the conference. Well, I'm Jason. I'm a father. Of course, I'm a nerd because I'm here. I love the Big Bang Theory, and love is a very, very, it's not as strong as a word how I feel about it, but I'm a big thing fan. I also love everything LA, especially LA sports ball, so huge Dodgers fan. I'm the lead support specialist here at Thumbtack. I'm also a board member of MacBrained. You can find me at those two addresses, either my personal one or you can find me on Twitter. You can also go check out macbrain.org for other information as well. So everybody's like, Thumbtack, what is Thumbtack? Thumbtack is my current employer. However, I have not implemented PF at my current employer. The reason why I got involved with PF is because of here, Lawrence Berkeley National Lab. And that was my view for 4 years. And some people may be wondering, what is Lawrence Berkeley National Lab, or what is LBL as it's called for? LBL is known for the Energy Star, which was created in 1992. So any of you guys have any Energy Star efficient home appliances, yay, Department of Energy. They're also known for the ALS, which is basically, it's the advanced light source, and it's a bunch of electrons that are traveling at nearly the speed of light, which forces into a circular path by magnets, and it emits a bright ultraviolet and X-ray light that shines down beam lines to experiment end stations. The ALS produces light in X-rays, in X-ray vision regions of electromagnetic spectrums that is 1 billion times brighter than the sun. And they also help create some of the silicone and some of the etchings inside of new chips like Intel that are in some of our laptops and things like that. So that's why the ALS is an important thing. They also, JGI, which is the Joint Genome Institution. And so they help develop and define the human genome with other national labs. They're also known for the Hopper and NERSC, and that's home to the Cray XC30 supercomputers, also Edison and the Cray XE6 supercomputer, and also for the Hopper. And they're currently working on a Cori system, which is supposed to deliver 10 times the computing capacity of the Hopper supercomputer. And lastly, they're known for ESNet, which is basically a high performance, unclassified national network built to scientific research to manage the backbone of research for over 140 national campuses as well as commercial networks. So the Department of Energy drove my reason for getting into PF and security of things related to scientists and protecting their data and their information when they're traveling abroad and or staying on our network, or just say going wherever they're gonna go. But Lawrence Berkeley Lab is the reason why I got started with this. So, why are we actually here? We're here to talk about the PF, the Packet Firewall OSX. So let's kind of just do a brief history about it, just for those who haven't heard of it or don't know about it. It was originally developed by Daniel Hartmeyer and is now maintained and developed by the OpenBSD team. PF is a stateful inspection firewall, and people may not know exactly what stateful firewall inspection means. Well, a stateful inspection deals with the state of connections. It can be described as a condition of a connection, and it will store the states of legitimate connections in a state table, which is a state of information. It's normally stored as a hash, which improves the matching of anything associated with it. Why use PF? Because you want to filter TCP traffic to clients and or server or network address on your clients. What is PF? It's the OpenBSD packet firewall that is included with OS X. You have to use PF because IPFW, or Internet Table, the Internet Packet Firewall was deprecated in 10.9. So before 10.9, of course, you guys just use IP tables, and that's how you were able to do it previously. But they got rid of that, they deprecated it, so now this is why you have to use this. It is a command line based tool. However, if you are not a command line person, there are GUI options available. I will say I did not use any of the GUI, so I do have options available if you would like to use that. I did everything on the command line that I had to. Additionally, what can PF do? It can provide bandwidth control, and it also can, and it can also do packet prioritization as well. So that's actually another option. So now that we kind of have all the information, we have everything that we need to have about it, let's go through what it takes to build some rules. So what are some use cases? Why would you actually implement this within your environment? One is server client protection. Think of one of your users using public Wi-Fi in a coffee shop. And how many people have, say, HR executives? How many people have even C-level executives or just basic EAs who are just going to a coffee shop? I'm gonna go have a cup of coffee before I come to the office. Oh, let me spin up my email. Let me spin up this service. Let me spin up this, or let me spin up that. And they're actually on public Wi-Fi doing whatever they're doing, which you probably don't want them to do, but they're gonna do anyway because you can't control it all the time. And one reason why we started using it is that when I was there, we had a tool called Casper. Everyone kind of knows about Casper and what Jamf offers. And we had a Casper server that we needed to communicate with clients on the outside world. And our clients do travel all over the world, so that they're scientists and some are world class, so they go everywhere. We want to make sure that we can protect them. We can also update them, SSH, do whatever we have to do, and then make sure also that no one can actually get inside of their systems. We also want to make sure that on our internal network, people weren't abusing or trying to do interesting things to those clients as well. So we want to make sure that only our management servers and or our management systems could talk to these clients as well. So that was another reason why we did this. And seeing that they are a national laboratory, users from all over the world attempt to access our systems. We thwart off thousands and millions of attacks on a daily basis. With PF, we can actually log these attempts and see who the people are and what they're trying to get to or what services they're trying to get to. And not to mention that it was an InfoSec mandate, so we had to help secure the server and also the clients just to make sure that they couldn't just get to that data. So what are some general use cases? Of course, you have servers, you use workstations, desktops, laptops. You can actually use it for gateways for Windows XP clients. At the lab, we had a lot of systems, microscopes that were actually built for Windows XP, and it costs millions of dollars to upgrade those systems. Instead of having to say we're gonna go, hey, Department of Energy, we need this much money to do this to upgrade to Windows 7, Windows 8, or whatever Windows platform that was needed for the microscope, you could put a system with PF in front of it, and you can filter the traffic in and out to be as a gateway for those systems. So that's another reason why you can also use PF and how you could use it. So let's break down what it took and what actually happens. So here are the basics of PF. So PF actually, if you go on the terminal and you type in pfctl, you do need to sudo up in order to actually make any changes, but you can just go pfctl. If you just do if you do a -e, of course, you can enable it. You can disable it with a -d. If you need to actually load the configuration file, you do your -f. Something that I really love to do is the nf, and actually I do nvf, and that's actually to parse but don't load any of your conf files, and that's super helpful, and we'll go over that in later detail. If you're trying to load a current rule set or the current state table, you can also filter your stats, and if you want to see all of the things, meaning if you want to see all the stats regarding how your firewall actually is performing on a minute or second by second basis, you can actually do that as well, and it will output it all to the command line for you. Don't forget, you also have the man page, so you can actually go there if you need to look up any other specifics that are related to PF. So This is actually, if you grep for PF inside of the /etc, these are the 3 files you're going to find. You're going to have PF anchors, PF conf, and PF OS. PF conf has 5 parts. It has macros, which are user-defined. They hold IP addresses or interface names. It's up to you which one, how you want to do it. Tables, you can use those to hold a list of IP addresses. You also have options, which are flags which control PF. You also have queuing, which is bandwidth control and packet prioritization. You have the filter rules that are located inside there as well. And these are user-defined rules about packets allowed to talk over selected interfaces. And this is the line of the file that's being evaluated when applying rules. So whenever you do actually end up loading your pf.conf, when there's actually a line in there that we're going to go over later, load, that actually is how you actually apply all your rule sets and what actually kicks off PF and makes it work. Inside of PF anchors, which is where we will be dealing with a lot today and where I'm going to highly suggest you guys deal with as well. This is where your sub rule sets can be modified on the fly using PFCTL. And it's also attached to the main rule set. And an anchor is a collection of rules, tables, and potential other anchors. Processing continues in the pf.conf in the main rule set unless the packet matches a filter rule that uses a quick option, which we'll go over as well. And everybody knows that when Apple ever releases an update of any sort, there's no guarantee that if you put your information in a file, say like the pf.conf file, that Apple is just going to overwrite it and put their file there, and next thing you know, all your rule set is gone. This is where PF anchors comes in handy, is because you put all your files in an anchor file and you put it inside of that folder. Apple is not going to overwrite that folder and overwrite your value for that. The pf.conf file, there's no guarantee they will do that. So this is why you create your own rule sets and then you load your own rule sets in. And there's actually the pf.os. That's a fingerprint file. It determines the remote operating system by comparing TCP send packets. So those are the 3 files that you need to, files/folders that you need to be aware of inside of there. So now that and then a little bit more is, like a little bit more about the basics in creating a rule set is, it is a collection of tables, lists, and macros to help provide inbound and outbound packets. By default, Apple has exceptions, excerpts and exceptions in the exceptions list that is put inside PF rules, which is included inside of its pf.anchors, and it's called com.apple. So if you're worried about blocking Apple-related services, or if you guaranteed, say, want to block Apple-related services, and you're going to use PF, there actually is a com.apple file. Just go and comment out all of those, and you will disable all of the Apple-related kind of services when you enable PF. So what actually is the PF rule set makeup? So this is the fun part. You have, of course, actions here. And an action that should be taken for matching packets, either a pass or a block. So whether you want to deny or allow, that is what the action is. There actually is direction, and that's the direction the packet should be moving on the interface, whether it's going to be in or it's going to be out. So you're going to have pass in, whether or not you want the packet to be logged. So pass in, log. Quick is basically the rule is considered the last matching rule when a specified action is taken. So what that means is, if you would like to see if a packet, if it meets a rule and you have quick on there and you don't want it to evaluate any of your other rules, if you put quick on the end of or put quick in the statement, it will say, it matches this one. Don't worry about everything else. Continue to process. So that way you don't have to go through the entire rule set to make sure that no other rules match that packet as well. You also have, of course, on interface, select the interface, because if you have multiple interfaces, you can also log on multiple interfaces. Or if you only want to do on a specific one, say wireless is the only thing you really want to monitor, you don't care necessarily about hardwire, or you only care about hardwire because you don't necessarily allow people to go on wireless and you want to make sure you log all that traffic, of course, select your interface. AF is your address family, and this is going to be important as we start to move towards IPv6. When it was IPv4, it didn't necessarily matter, but it definitely deals with IPv6 and IPv4. And so the actual language is going to be INET or INET6. So if you do want to log a specific either IPv4 or 6, you can actually do that. Or if you just leave it open, it can do both if you need to do both. And of course, there's also the protocol, and that's up to you guys. That's a layer 4 protocol of a packet. So you're talking about TCP, UDP, INCP. If you're going to do IPv6, INCP6 is another one, and those are just valid protocols. You can find those in actually the /etc/protocols folder. You can actually go inside there. You can actually get the proper names for it when you're labeling it, because you just can't. You have to use the proper names when you're building all of your rule sets. Then, of course, from source address is whatever source address. If you have a specific one that you're trying to monitor, which at LBL we definitely did. If you have a port the source port, if you know where it's going to be coming from, you can always do that. To the destination address or to the destination port as well. So if there's ones that you're actually trying to monitor specific ports. And there's also, if you're trying to monitor specific flags, TCP flags, you can do that. And then state, of course, if you are going to keep if you want to keep the state, or if you want to make it persistent, not persistent, depends on how you really want to go. For outbound traffic, that matters. Inbound traffic, that's going to be up to you if you really want to kind of keep the state on that, or if you want to keep monitoring everything on top of that. I will say, as a caveat to state, in newer versions of PF, you don't need to put state in if you're going to pass out traffic. If you do pass all and then keep, you don't necessarily need to do the state. You don't need to keep state. You can just do pass out, and then it will actually keep the state currently. So it's only on older versions of PF that you have to actually worry about the keep state. So let's talk about list macros and tables. Oh my. Everyone may wonder kind of what it is, what goes on. It's very similar to programming and when you're making lists and tables inside of those same things. Lists and macros, they create and maintain rule sets. They make it easier to actually do that. Lists allow for specification of multiple similar criteria within a rule. And you can actually have lists can contain nested lists. So the use case for this would be a list of IPs. If you have 4 or 5 servers that are doing one specific thing, you can actually put all of those in one list. And then when you make your rule set, you can actually just refer to that one list value as a variable versus saying, let me go create 10 rules with these 10 different IPs. Lists are actually amazing. I use them all the time. You should too. That's what I would highly, highly suggest. Macros are user-defined variables, and these can hold a whole lot more. You can do IP addresses in there. You can do port numbers. You can do interfaces, interface names inside of a macro. Names must start with a letter and may contain letters, digits, and underscores. But that's very important, but they must start with a letter, so you cannot start with a symbol, a dash, an underscore. It must start with a letter, so that's very, very important. They cannot be passed out or queued. We're going to assess what that means later. And using a macro is great for network interfaces. So if you have, say you're monitoring 3 or 4 different ones, I would make a macro out of that so you can combine it into one. So when you write your rule set, you don't need to write a rule for every single interface. You just have a list of interfaces inside of a macro that then it will all monitor. So then it will work better for you as you go around. So people may be wondering, what is the difference between a list and a macro, because a macro can hold many things that are similar to a list. The difference between a list and a macro is that a list cannot contain a macro, but a macro can contain a list. If that kind of clarifies what the difference is between the two. So definitely something that you can use and that you can go forth and conquer with, and that can work for you without any problems. So let's kind of look at what it is. So if you look at this rule here, we have a block in. So we're going to block in. We're going to log all traffic on Eno0 that's IPv4 related from your local interface. And that's all that says, and that's all that does. Same thing for the next ones. Only difference is that we just change the IP addresses. So that's a kind of a sample of what it looks like. And this is what you could do with lists and macros, is that right now you have those 3 rules to block everything just for them 3 different IP addresses. And that's just a waste of space. What you could do is you can go block in quick. So you're going to block in, you're going to quickly evaluate anything that comes in these, and if it evaluates true to this statement, then you're just going to, keep going. Don't parse the rest of the rules. On eno0 from, you have all three of your interfaces, and then you're doing to any port. And from there, you've taken those 3 lines, and then you can put it actually into 1 line, depending on how your stuff is structured, but that can only be 1 line for yourself. And so you can keep it simple, clean, without having to go through and then write that for every single one. So that's how you can use lists and macros to your advantage and make them work and flow for you without, the clutter. And then a sample of a macro is you can do, if external interface is, and say it's FP0, you can also do it where you can do it like this, ICMP types, and you can do the echo apply, echo reach, time X, or unreach. And you can plug that into something as well and turn a list of interfaces or response types into a macro. And so those would be the benefits of the macro if you want to use macros instead. And I would highly suggest doing that. That's actually what I do for my rule sets, especially for ICMP types. I don't want to have to write a rule for every single ICMP type. I just want to have them all in one and then make it a macro so then you can move forth and conquer with it. So let's talk about tables. So tables are a method to help group together a range of IP addresses. It's a list of IPs, IP addresses, which can be manipulated without needing to reload the entire rule, the rule set, and where fast lookups are desirable. So tables are enclosed with the greater than, less thans. And then const stands for contents of a table cannot be changed once a table is created. So if someone is trying to modify rules on the fly and you have the const in front of that, you cannot do that. You need to actually remove that from in front of your table to make sure that it can actually be modified. So this is more like a static or, in essence, like a global variable. It just cannot be moved. It's not going to go anywhere. It's going to be there all the time. And then persist, it causes the kernel to keep the table in memory, even when no rules refer to it. If your table doesn't have this option, the kernel will automatically remove the table when the last rule reference is flushed. So this is another example of you can have table blocked as host, anything on the 192/24 subnet. And then what you can do is a table of my infrastructure. My infrastructure shouldn't change. Someone shouldn't be able to go into, say, my PF rules and go in there and muck around and change the IP addresses on my infrastructure and say, all right, let's do this. So I make it a constant, so it will always be there. And I add in all the subnets of where, IPs of the subnets where my stuff would be. And you can just put this table, my infrastructure, and then you can plug that into a rule that says my infrastructure, and it will refer to that table, and it will go there, and it will never change. So you never have to worry about your information moving. There also is, and here's another example of block in on this particular interface from this table. So you can actually have a table, say the block host was this, that will refer there. If you had spammers was my infrastructure, all these IP addresses were there, and it would block in to any port. But then you can also have a list of, say, good guys, which could be your cybersecurity scanners per se. And then you can allow them to pass in on that interface to any port on the system. That way they can scan or do whatever they need to do for that particular reason. You can manipulate tables on the fly as well. So if you create one, you can do pfctl-t, the name of the table, -t, and then add in your list of tables. And you actually create that on the fly without actually having to go inside of your pf.anchor file, modify that, flush the policies, check it, reload it. If you 100% are confident in what you're doing, this is another way if you need to do something really quick on all your systems, go through and then plug it through so you can have it happen right away. I wouldn't always suggest this, only because you'd want to verify, of course, that it didn't modify any of the rule sets or that it didn't break anything inside of your files, but this is an option per se in an emergency situation. So this is actually something I use on every, oh, not that, I messed that up, I'm sorry. But this is what I use on every single rule set that I create. I disable all filtering on loopback and possibly VMware nets because I don't need to have any of that information logging onto my system. Especially I spin up so many VMs, I just don't need to have any of that stuff. So I skip the set on those two things, and by default, I block all inbound traffic. There is no point to implementing PF if you're not going to, by default, block in all traffic. You're using PF to filter in the traffic that is hitting a device, and by allowing everything to touch your system and touch your device, you're just defeating the purpose of it. You might as well just leave your application firewall on and call it a day. So you must, by default, block in everything and then choose what you want to touch your system. Choose if you want SSH on, if you want a file share from here, if you want your cybersecurity scanners, because whatever they're doing, to touch your systems. Make explicit rules and define explicitly what traffic you want to be touching your systems and your interfaces at all times. So this is the kind of default besides the 49. This is the default that you actually want. You want block in, log all, because you do. You want to see also the stuff that is trying to touch your machine that shouldn't be. And a prime example of this is when I was at LBO, I actually turned this on my just personal system before I deployed it out to everybody because I just wanted to play with it. I wanted to see what happens, what goes on. And as I started combing through my logs, I could see people from China trying to scan my system and trying to look at my system. I could see people from other countries who were literally just trying to manipulate or just see what holes or vulnerabilities I had open on my system. And this was because I had block in and then log all, I was able to see the amount of people who were trying to touch it. And that was very eye-opening for me, and that's what definitely pushed me to escalate my deployment of the system, especially being a national laboratory, is I wanted to make sure that we were protected at all points in time. Now, granted, our cybersecurity team, there's other protections in place, but if they were able to scan my system at that point in time, I knew that, you can't catch everything. The bad guys usually are steps ahead, and cyber is usually playing catch up to try to prevent certain things from occurring. So this is very, very important to do if you do set up your rule set. So this may be a little hard to read, and I definitely apologize. I tried to put all my rules that I currently have kind of on there to give you a sample set. But this is how your rule set is going to end up looking. Now, this isn't your entire file. This is just purely just the rules, and we'll step through this slide all together. So I'm going to allow TCP and UDP traffic. It's very important that you guys do allow for both. Does anybody know of a service where it communicates both on TCP and UDP? That's kind of critical for, you don't necessarily know all the time which one it's going to use, but it's just going to use one of them. DNS. That DNS was the answer, and that's exactly why you need to make sure that you write rules for both. Don't just do TCP or just don't do UDP. DNS is a prime reason when I implemented these rules, I didn't think about that. That was the one thing I didn't think about. And one day I went to my system and I found out that, hey, I can't get an IP address. And I'm sitting here, I'm like, what did I do? I go, I didn't go to any bad sites. I didn't go to anywhere. I didn't download anything. I don't have anything. Why is cyber blocking my system? So I email my cyber team and I say, hey, the system's blocked. Here's my MAC address. Could you unblock me, please? And they go, you're perfectly fine. We're not blocking you. We show that you had a DHCP lease. Your system's still trying to acquire one. You're fine. Go away. Bye. And I was like, I've worked with these guys all the time. I know they're busy. They wouldn't just send me on a goose chase. And so then I was like, right. I turned on PF. And I go inside my rules, and let alone, I add in a DNS rule for TCP and UDP. And next thing you know, magic, the internet starts working again. So you definitely want to, that's why it's important to make sure you know which one is which. But as you go in, I pass in, I log from the protocol TCP from any of my, at the time, the group is called MPSG host, to port, and it's labeled TCP services. And I will show you guys what TCP services means in just a second. And then I actually route the same rule for UDP services. We use a tool called BigFix. So I wrote specifically for UDP from anything MPSG BigFix to that port and to write over. We have OTP service as well. So I made sure that only our OTP servers could talk to SSH as well. There actually is also to log in any protocol TCP from any port to SSH. So anybody trying to talk to that particular port, I wanted to make sure I logged in. I did pass it in, but I just verified. I could have blocked anything to that particular port and just say, only allow my Casper host to talk to that port. But because different services do need it, I did want to allow traffic to pass in there, but I wanted to log it and just to make sure. I also allowed from any port TCP, any of our Casper communications. Everyone knows, or not everyone, Casper does need 8443. Depending on how secure you're going, you could just use 443 and you can just use 80. There's different things you can use. So I made sure that all the comms related to Casper were able to be used and utilized. I also did add in my DNS and my DHCP to make sure that all that can communicate properly. I did make sure that I have whitelisted hosts to make sure that anything that's 100% okay, I'm going to allow any of my whitelisted hosts to talk to any ports on my clients and on the systems. Because there are systems that you guys do allow that say, these are 100% okay. These are systems that we trust, we know, we run, we utilize. These are whitelisted, they're good to go. I also have MPSG service host here, where I can pass and I do log from MPSG hosts. They could talk to any port on these machines as well. So no matter the port, doesn't really matter. I will allow any of our internal services to communicate to the clients on any port. Depending on if you have routers, I did change that, but if you have internet group messaging, you can allow that to talk and communicate properly. As well as this line is probably the single most important line probably the third most important line you can have in your stuff. Pass and log on IPv4 protocol, INCP, the ICP types, and then I made a macro for all those types. If you turn on PF and say you're having a problem on your network, you need to ping a device. Simple, just ping it. If you turn on PF and you don't have this rule in particular, can't ping it. PF's gonna block it. It's gonna drop the packets. It's gonna log that you attempted to do that, but you actually can't troubleshoot to say, oh no, this system is actually live on my network and it's good to go. So you do need to make sure that you write rules in for network troubleshooting for your technicians, for your security team, for your network team, because they're gonna go to NSLookup, ping, they're gonna try to do whatever they're gonna do to the machine, and PF is just gonna be like, nope, sorry, thanks, goodbye. So for your sake and for your tech's sake, definitely implement that inside of there. And then I actually wrote a note here. It's kind of hard to see with that gray. I apologize. And I just said we specified the address family INET because it's required when specifying the ICMP type. So that's the only reason why INET is there. So you definitely, if you guys are going to utilize IPv6, I would also add the INET 6 rules inside of there as well. And the last one is this rule here, pass out all, keep state. The last thing I wanted to do was prevent somebody from starting an application, say, on their system, say Dropbox or Google Drive or any cloud syncing application or even just a standard web session, and I'm blocking that traffic from going out and constantly coming in and out on the machine. So by passing all, keeping the state, you're basically allowing someone to say, I'm gonna go to gmail.com, keep the connection open, and let it go. Now, I am not logging that traffic. You could log that traffic if you would like. Your cyber team may actually already log your network traffic, depending on where you are. I was at a government agency, so of course, it was logged already, so I didn't need to necessarily log that traffic. But you could if you wanted to. It's totally up to you, but I would do that rule because you don't know what people are always running. I mean, does anybody know every application 100% that's in their environment? If you don't, that rule is going to be key to make sure that you don't break anything. And that was the last one, the outbound rules. Pass all, keep out. Do it, do it, do it, please. And something that I want to stress, and I'm probably going to stress over and over and over again, is now that you've compiled this rule set, test. Please don't compile your rule set and say, it looks good, it's solid, it's good to go, I'm going to roll this out, and don't test. Because I promise you, you're going to break something that you don't intend to break, or you're going to deploy a rule set that actually doesn't work. My first rule set that I actually deployed on my own personal system that for testing purposes did not work. My parser threw out all types of errors of, hey, you forgot this, you forgot that, this actually doesn't match here. It does give you specific lines of where something is broken, luckily. So you can go back to those specific lines and figure them out. But testing is so essential to what you're doing that test, 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 test. I can't say it enough. Test before you go into deployment, please. So what's the second to last rule step, step of making rule sets? It's here. Is inside of your pf.conf, so inside of /etc/pf.conf, to add in your custom anchor. This is what's included by default. And that load anchor com apple from Etsy pf anchors com.apple, that's what lets Apple services still talk when you enable pf. And what this is doing is it's going to scrub, it's going to nat any of the anchors. The RDR and the dummy net don't really matter as much. The ones that you really need to focus on is you need to add a scrub anchor. So I have scrub anchor com.json. And I also have anchor com.json. And then I make sure to load the anchor to make sure that my rule sets actually apply. Because you could turn it on and you could be only loading just the Apple rule sets, and you're not actually protecting or doing anything for that matter. And you'll get a lot of traffic that is not what you were expecting. So this is kind of the last step, second to last step is making sure that you put in these correct files in the correct places inside of your etsy.conf. You can actually just copy these and just fill in your name or your anchor file, whatever you're going to call it. So whether it's com.json, gov.lbl, and you should just want to call it like that. So what is the last step in making all of your rule sets? Test. You laugh now, but just wait till you need tech support. Like I said earlier, testing it's critical. And as you see, I'm a huge Sheldon fan. But testing is critical. Making sure you communicate this to your teams, whether they're your internal and your external teams, having a test group to make sure that you don't break anything. So if you have engineers, if you have scientists, whoever you have, sales, marketing, whatever you have, is making sure that you actually go to them and you say, I need one person to test this, validate that these actually work, and also validate that you don't break any of their workflows, and that you're actually logging information, or that it's actually filtering information the way that you expect it to filter based upon your rule sets. So please test, test, test. And like I like to tell my wife and friends all the time, trust but verify. Make sure that you are matching up all your rules and your rule sets. So if you do pfctl -nvf or -sr, this actually will print out your rules in more or less human readable state. So if you need to go to someone, a C-level person or your manager or your boss, you can tell them, this is what we're actually doing to the machine, and this is what we're doing. We're worried about certain services, SSH, 443, DNS, DHCP. We're worried about, say, being able to reach the machine, ICMP types. We're blocking in all the traffic, but we're going to allow pinging. We're going to allow say just DNS or DHCP traffic, and we're going to keep the state on everything else. And this is something that you can easily provide to them in English, more or less, without having to give them the actual rule set of what you wrote, because they're going to go to you and they're going to say, well, what is all this? What is this? What is this list of IPs here? What is this? You could easily, as you go through this, is that you'll see allow our host to talk to port 22 is what you could, in theory, write when you do your printout. So you want to use human readable variables as far as tables, macros, and lists are concerned, because when they print out, they're going to print out in this nice little list that looks just like this here, that you can supply to anybody and just say, this is actually what we're filtering, this is what we're monitoring, this is what we're trying to protect. PFCTL space -SR. And that will print this out, and you'll get something clean, neat, and simple, just like this. So we've gone over the basics. We've created a rule set. What about logging? Logging is probably the funnest part of this whole story. Logs are not included in PF. PF does 0 logging. So when you go to implement this, you need to figure out how to set up logging for PF. And when I first did this, I was just like, yes, this is awesome. I'm going to turn this on. We're going to monitor. I'm going to pipe this all to a log. It's going to output all this information. Cyber will be, they're going to love me. And then when I turn it, I do it, and I go, crap, I'm logging nothing. It's blocking and it's working. I'm getting stats about what it's blocking, what I'm filtering, what I'm allowing in and out, but I can't actually prove that I'm doing it. I can't prove that it's working. I can't prove that it's not working. So in order to do that, you have to create your own. And that's exactly what I did. With a mix of TCP dump, proper permissions, and creating a launch daemon, I was actually able to log everything that I was doing inside of this. So how did I do it? First, I did create a script. And what I did was I wanted to gather the PF log data from local 2, and I wanted to pipe it to a pf.log file, which is going to the syslog.conf. So all I do is I just touch it. I change the root, change the permissions. I make sure root can own it. I kill the syslog, and of course it comes back, and now root owns the log. So I just create just the bare bones log to do this. After that, what I then do is I actually create an interface called pflog0, and then I do a TCP dump, and I pipe that in the logger, which goes into my local2.info. Now, some people may be wondering what this is or what these commands actually do, the extra flags on the TCP dump. So this is where you guys can control how much output you get from TCP dump into your files. So depending on the information that you want and or need, these flags will definitely vary. But these are the ones that I chose. So the -L is makes standard out, makes the line buffered. The -E will print the link level header on each dump line. The -I will specify a specific interface. So if you do want to, say, do multiple interfaces, or if you only want to do one specific one, the -I, so that way you can do that. If you want the -N is don't convert the IP addresses to names. That is going to waste precious seconds during this process, say, of logging this information. If you're going to convert every single IP address to a host name, I just want the IP addresses. I don't want the host names. I want to see what IP addresses are constantly trying to, say, talk to and or attack my machines. So I want to know IP addresses and IP addresses only. And the 3 T's are, it's going to print a delta or a microsecond resolution between your current and the previous line on each dump line. So then you're going to be able to get by the microsecond interactions. If something is happening, it's going to track that. So there are other flags in there. There's 4 T's, there's 2 T's, depending on how quick you want to get these transactions or interactions, say, logged. TCP dump has a wealth of options that you can use if you would like to. So these are the ones that I just chose to use for my specific instance, and this is what their requirement was. So this is why we went with these particular flags. And of course, I change it, make sure that root actually owns the file. I don't necessarily want my scientists who know what they're doing to be looking inside these logs or mucking inside these logs or, say, deleting these logs, because they can and they don't want necessarily us on their machines. Not knowing that, we want to make sure that if there is an event happening, we want to be able to point back to a period of time and look at some logs to understand what happened, when the compromise happened, or when a said attack happened. So this is why that was important, to make sure that we actually set all of that up. And then lastly is ensuring that you set a launch daemon. So that way, every time the system actually boots, it actually does what it's supposed to do. So of course, you create a pf log. I actually store a script that it's going to pull up. I run it load, keep it live, change the name, and then I do a launch control, listen for it, I load it, and then I make sure you should see the pf log after that. This stuff and all the information, if you're trying to jot it down, it's actually on my GitHub already posted, so you guys can just go to GitHub. There's links at the end for it, so you don't have to worry about that. The scripting or any of the plist portions of it, you can modify it as needed from GitHub. So that's actually what I did to set up logging on my system, and what I actually did to kind of get it going and all this other fun stuff for cyber reasons. So the last thing that I wanted to focus on was monitor. And how do I monitor, and how do I do all this other fun stuff? Excuse me. I actually just recently was able to, as I was thinking throughout this, that's horrible. I apologize. That's absolutely terrible. I set up the Elk stack, which is a mix of Logstash, Elasticsearch, and Kibana. And these actually this is the live traffic just from this conference yesterday that hit my machine. And this isn't even a full day's worth of traffic that hit my machine. This is, if you look, well, you can't really see, but here is about 10:30 in the morning. I turned it on. It goes to that's about noon, 1 o'clock. I shut down for a while. This is, 3 o'clock, shut down for a while, turned it on for a second. And then this is late last night as I was sitting in Legends. And if you look, it's 500,000 hit my machine that my PF firewall hit just from here in under 8 hours. That stuff that I blocked, garbage, crap, whatever it was, that didn't hit my system. And the reason why looking at it in a graphical format is very important is that you can spot trends. You could see if a certain IP address is starting to talk to certain clients on certain ports, depending on how much information you decided to log. If you want to see what time of day was busier than other times of days, putting it in a visual format will definitely help you versus trying to comb through tons of logs that you aggregate onto a single, say, logging server of some sort. I just chose to spin up the Elk stack because it was easy, free as another thing, open source, so you can just go ahead and you can set this up to get alerting yourself. And I just think it's important for everybody to know that you guys can do this. If you have another logging tool, please pipe it into there so you can get a view of what you're looking at. Splunk. If you guys can afford Splunk, go for it. Do it. I personally cannot afford Splunk, so that's why it didn't happen. But any logging tool of a GUI, of course, that you can do, go for it. I think it's critical for you to do that and for that to make it happen. Now, some people also may be wondering, there was no love for the GUI during this whole conversation or during this whole presentation. I think GUIs are awesome. They do allow you to do sometimes complex things in a simple manner. But for me, I thought it was easier to use the terminal and VI and go in to edit just raw text files instead. And then it's easier to pipe out. You can also version control it better. So if you're working with a team of people on rules and they want to modify them and make changes and edits, it was just better for me. But if you love the GUI, there are options that are available to you. And one is HandyNet IceFloor. And they write a tool. You can use that if you would like. That's another one that's just great for if you want to build quick rules, just click, click, click all the way through. Another one is one called Firewall Builder. Google Slides did not like these images. But Firewall Builder is actually another one that you can actually use if you want, just fbuilder.org. Lastly, there is Mirrors Firewall, which actually is one that you can use as well if you would like to go anything on the GUI. So those are the three options that you guys could use for that. If you don't want to use the terminal, you aren't comfortable with kind of modifying the files in just the Etsy folder, those are ones that you can do. Now, when I started this, my PF journey, we were on, I think, 10.8 or 10.9 is when I started kind of going down this rabbit hole. It has not changed for SIP reasons or anything like that. So you don't have to necessarily worry about, oh, this isn't going to work in this era and this time. We'll see. I haven't played around with Mac OS Sierra yet and PF, but it does work, say, pre that. So you don't have to worry about if I make a change here, is it actually going to apply there or here? So you can do that as well. And some may be wondering about what about the packet, the bandwidth control, and the packet prioritization. PF does offer this functionality. However, it's not just in the scope of this talk. So I won't be going in detail kind of how you can use that. Maybe next year if I have time to kind of put one together and worry about that type of stuff. But this is where it's just not covered, say, for this particular one. Here are a list of resources that I actually used during my journey for PF. Cryptid was very awesome. I actually wrote some blog posts about it myself where I went in detail about it with a buddy of mine who worked at LBL. Also OpenBSD, seeing that they are the maintainers of PF. It's a great resource. They have all their documentation all online. It's really good. So I would definitely take a stab at that. I actually read, there actually is a book about PF. I forget what the name of the book is, but I read this book in about a day because my cyber team was so hot to trot for PF. So there actually is a quality book. I actually think it's the nostarch.com/PF3. I think that's the one where you can actually go get the book. My GitHub is there, so if you were looking for the links as far as the logging setup is concerned, that's actually there. I did actually post also a sample rule set that you can just more or less copy and paste and then play with yourself. So you have to go through and build a lot of those same rules again. You can kind of plug and play and just test for yourself. Of course, man pages. Those are always awesome tools that you can actually use and do any of that fun stuff. So definitely use these resources, use the community, people on the Mac admins, people on MacBrain. You can find any of them anywhere who have just deep or have a good knowledge of this, maybe not deep knowledge, but a good knowledge of this. Please use your community resources, definitely go over it. And in closing, I just want to remind everything about one thing. Networks are hard, but people are soft. Understand that your people are going to be the weakest thing that you can, that's what you need to protect. Networks are, they're standard. Like, you know what's going to happen on a network. You know how it's going to communicate. You know how it's going to ebb and flow. You know what's going to happen. You can harden a network to your heart's content. But if you don't educate your people about how to use their machine, what to do, why this is a good thing, why that is a bad thing, all of this is kind of going to be for naught. So definitely understand that that's kind of how it flows and what it does. That's awesome. So I appreciate all your time and effort today for listening to me babble on and on up here. Feedback URL is there if you have anything that you do want to say and or do. And I will take any questions about anything. And actually what I will do, thank you guys for using the Ask a Question. I thought that was awesome. I was in a presentation yesterday, the first one I saw, and they had that, and I said, yeah, that would be an awesome tool. Someone said, have I used the firewall? I have not. The Mirrors firewall tool. I strictly stick to the GUI because it allows, or to the terminal, it allows me to update more frequently and quicker, and I can parse my rules. So if you just want to test something really quick, I would just have no clue how to use that GUI tool. I haven't had the urge to actually use a GUI with PF just yet. Another question was, if you had pass all keep state turned on, would you still need to specify DNS traffic? And if so, why? You would not have to actually, if you have that turned on, whatever was going out, you would not have to specify. And your rule that you already built into when you pass the DNS traffic in and allow it to kind of go back and forth, that will actually allow it to stay and come in. And when you pass it out, it'll just keep the current state. So you don't have to worry about creating a rule for that reason. Another question was, does the outbound rule you have at the end allow in traffic from any session that was initiated on your end? So I think I should probably go back to look at that so I can actually see. It's back there pretty far. Are we talking, which rule are we talking? If
Pass out all flags.
so, this is just pass out all flags. So it was, rule at the end allow traffic session that was initiated. Yes. So this will allow any traffic that was initiated on my end to keep going and to come back in without any problems. So you don't have to necessarily worry about, hey, I'm going to block this particular thing. This will actually keep it from coming. It will keep it coming back and forth. Another question. Oh, good. I can scroll on this one. Are Apple defaults rules a good starting place, or is the com.apple tool too liberal at what it allows through? Harry, I'm not sure. I'm trying to there. It is actually a bare bones rule, and if you want to see it, here, I'm going to show you what's actually in that particular one. Let me get out the full screen here. All right, and I'll show you actually what's inside of it. So this is my log stash running on the background. That's traffic still hitting my machine. And if you go inside of that com.apple folder and you look at that file, that's all they're doing. They're allowing the application firewall, and they're allowing that to go through and pass traffic on an application basis, and they're allowing the airdrop. So that's all they're actually doing inside of their anchor and nothing else. So whatever all their services are, that's what they allow.
So when you were replacing in the comp file, you changed it from their anchor file to yours. That's all
I'm doing. Yeah, and I just load my particular file, and I'll even, so if we go to, so if you're going down, and I actually commented out all their stuff, because I was just like, the application firewall, yeah, it's awesome. If I need to do it, it'll pop up, not a big deal. But this is actually what I actually run. And I load my anchor, I scrub it, I nat it, I point to it, and then I load it. And that's all it's doing. So can PF filter differently based if you are connected on an encrypted or a non-encrypted network? So if your network traffic is encrypted, it's only going to capture the first, say, 64 bytes of information actually on PF. So in those first, if it can filter it based upon those first 64 bytes and there's enough information in there, it'll do it. Anything after that, it won't. So I hope that answers the question of the anonymous. Yes.
So, is there a processing order that's good to note here? I'm a little confused, I guess, because you have the block drop in,
Oh, here.
and you got the pass ins below that. So I'm just wondering, is ordering if these statements matter? I mean, what's the processing order?
Yeah. So it does more or less, because if you have a quick, so by default, you want to block it in all. And if you don't put that in as the very first rule in your rule set, and you say you put all the passes above, you're not going to block any traffic. So that does matter as far as just setting up that default block rule. But also, if I came into your environment and say you implemented PF and your block was down at the very bottom, and as I'm scrolling through and you have hundreds of rules, I would not know that you had that inside of the rule at all. So I'd be like, well, why are we even using this at all if we're not even going to default block anything in? So if you don't have that at the very beginning, it's not actually going to protect it the way that it needs to protect it. So you'll need to put that in there. And as far as the rules, it doesn't actually, for the bottom part, that doesn't really matter because it's going to packet match based upon the rule. And so if it say on this rule, say at the bottom here, if a packet keeps going through, it's going to see if it matches this rule, see if it matches that one, that one, that one. If it matches this one, great. It will quickly check the other ones unless you add in the quick inside of this. And then when you add in the quick, that's when it'll go, all right, I'm done. I don't need to match any of the rules. I'm going to keep going.
So is it always last rule wins?
Yes.
So if you put the block at the bottom, then it would block everything,
It could, in theory, yes.
except for any quick.
Except for any quick. So if you put quick on anything, then you're going to allow everything in. For that rule, if you do quick. Quick matching is pretty awesome if you definitely are 100% say definitive on if it matches this exact thing, say SSH. I only want one SSH server to be able to communicate to my machine. And anything else SSH-wise, any other rules that you have associated with it, whether you're going to block or do whatever you're going to do to it, or if you're going to filter it and say do whatever, if you want to ensure that only one particular server can talk on, say, port 25, because you're going to change your SSH port to that for this particular service, then you can say, even though it's coming in SSH, go here, quick rule, filter it out, and then it won't evaluate for any of the other SSH rules that are coming through. It'll go specifically to that port and say, all right, I'm done. I don't have to evaluate the other SSH, say, rules that you have about your OTP server or another server, if that clarifies a little bit. No? Okay.
Can you do any blocking based on like SSID of a network? Like a wireless network?
Sadly, no. So it's going to have to be just on the network interface, not necessarily on the SSID. And I have gotten the question of someone said, can I block Dropbox? And you can actually just block, if you have, say, the range of IPs that Dropbox uses, yes, but you can't actually type in dropbox.com and expect PF to block it. Another question was, let me come back over. Are there any concerns for network traffic if you turn this on for all your devices and pipe the logs to a central server? Depends on your network. If your network pipe is big enough, the log file is pretty small, and as long as you're rotating the log file, you're good to go. You shouldn't have any concerns of sending it all there. I would not do log transmission in the clear text. I would definitely make sure that they only do it, say, on network or on VPN, somewhere along those lines. So make sure whenever you're doing your log forwarder, you set up those particular rules, but you shouldn't see anything that's going to harm your system. It also harms your network. It depends on how often you're going to be collecting these logs as well. I'm running it locally on my machine, so of course I'm getting up to the second updates. That may not be the case for many of your networks. You may say, I want the logs every 2 hours. And then if you randomize, when people are sending them in, it may not actually have any true effect on network performance that it's going to be measurable. But if your network is a little bit slower, you may see something. Another question is, did your central IT mandate use of PF, or did you implement this on your own? A mix of both. So because Casper touched human resources machines, which touched PII and it touched other sensitive information, that was a big gaping vulnerability in our InfoSec's concern. And so they said, we need you to figure out a method of making sure that any communication to these machines for SSH was 100% locked down, and then also figure out a way to make sure that you just secure. Since we're going to be doing HR, you might as well do all the devices. So then we floated IP tables, we floated PF, we floated Little Snitch. We floated a bunch of stuff to do. Yeah.
It breaks everything.
Yeah, and if you don't know how to use it, it's fun too. Yeah. There's concerns and thoughts that I have about that, but that's over a beer. But those are things that we definitely floated, and they just said, figure it out. And then from there, I had a lovely gray beard who worked at LBL, and he just had some ideas and said, these are a bunch of ideas that I think that we can do. He goes, it's up to you, whichever one you want. And as I started researching all the ideas and looking at all the stuff, I just said, hey, I actually like PF. It's flexible, it's friendly. I can roll out updates without any problems. It's in essence just a X file that then just gets loaded. I think that's probably the easiest way, especially if I want to version control and manage it and do different things like that. So that's why I chose, that's what actually did it. So it's a mix of both cyber and a mix of kind of my curiosity at the end of the day. So how do I handle different network interfaces on our rules? For us, we only cared about one particular interface, so I actually did not handle different interfaces. I didn't go through and specify if you plugged in here and you plugged in there. At LBL, we only had a concern about one particular one, so we just monitored that particular interface. But you could go through macros and then specify, in essence, every interface in ifconfig, and then forward it all that way, and then you won't have any problems. But we were only really worried about one in particular because one was just a little bit more vulnerable than the other. And for us, it was more or less Wi-Fi, especially when people weren't at the office. They weren't going to be plugged in. So that's all the only thing that we necessarily we were concerned about.
Looks like you skipped the question. Someone's asking,
Oh.
how do you deploy and modify the PF rules at scale? Gary?
Oh, I sure did. I'm sorry, Gary. But yeah, that was the other question. But yes, how do you deploy? So it depends. It depends really what your tool is. I mean, if you have Casper, you can always push it out as a kind of a DMG file if you want. Or if you use something, say like Facebook and what Mike Dodge and what they did, where they actually ran a local repo, or they had a Git repo that they were able to pull files on and off people's machines. Or if you have Chef or you have Puppet, you can make a manifest where if the file doesn't match this particular one, put it back on there and do it that way. That's the way that you would deploy it. We use Casper at LBL, so that was the tool of my choice. However, if you move forward and as you move forward with tools, things probably like a kind of Puppet Chef would be a great choice for that, because if anybody tries to modify that file, Puppet and Chef will make sure that it goes back to that exact file. So that's what I would do moving forward, say at my new company, and it's something that I'm looking at actually implementing just for this exact reason. Sorry, thank you, James, appreciate that. So let's see. So how are you deploying different rules to your clients? So when I rolled it out at LBL, a little bit after, within, I would say a month or two, I ended up actually leaving and going to my new company. So I didn't get a chance to say update that. But the way that I would is just use whatever deployment tool, or go to make your manifest, Puppet Chef, make the changes. As soon as they don't match in and they check in, they'll be good to go. But I would also, one thing that we didn't do very well, I would say this, is the communication side of it. Communicate as much as you can. Over communicate what these changes are to your broader community. Hold brown bags. Do everything you possibly can to ensure that they understand the changes that are coming and the changes that are affected. And then also let them know that if any of their services don't work, let you know as soon as possible. Because I promise you, they're probably the only person that did report it, and there's probably 50 other people who have the same problem that just aren't saying something. So definitely make sure you communicate the changes, and then also be receptive to any feedback saying, please let me know as soon as possible so we can make other changes as well.
If you do make changes and you deploy them, do you have to say at the end of the package that's laying down those files, so just text files, say like a post install that will restart PF?
Yeah, so after you do the whole fun thing, you can actually do it where you can load the current rule set, or you can go through and say, hey, I've made changes to this file, load this one. And then it's like pfctl, I believe it is -f will flush the current rule set, which then will, once it flushes, it will load the new one, and then you're good to go. So you want to make sure that you flush the old one, so you then can implement the new ones. And then how do you handle updating the rule sets on multiple machines? I kind of think that was in line with Harry's, but if not, please let me know and I'll try to elaborate a little bit more. Any other questions and/or concerns or any feedback about maybe something you guys did that was a little bit different for those who have used it before? Yeah.
I know I'm actually, I had just implemented PF pretty much right before I
Oh,
left.
sorry, wait. We're gonna use the catch box. Let's make this happen. Yeah, hold on to your laptop and your drinks, please. Yeah, it's on. Sweet. Ready?
So I was saying, right before I left, I actually was in the process of implementing PF because we got blocked by some of my machines got blocked by our information security office for having certain ports exposed and everything. And so I was like, okay, I'll finally learn PF. And I did a dumb thing and forgot to set up something to re-enable PF at launch, like on startup. And so one of those machines rebooted. Everything had been working perfectly, and then it got blocked again. And I was like, and this is while I'm sitting in a session 2 days ago, and I'm looking at home, and I'm like, whoops. So just as something for everyone to note, that's a mistake that's easy to make.
Yeah. Definitely use the create a launch yourself. It'll do wonders for you. All right, there it is. No. Well, thanks, guys. I appreciate your time and effort, energy. You guys have a wonderful rest of the conference.